Hi, this is part 3 of my videos on how to create a fully functional replica of the Antikythera mechanism. In part 2, I've shown you the lower part of the planetarium with the mechanisms for Mercury, Venus and the Sun. I've now finished the upper part of the planetarium with the only exception of the moon pointer, which I will show you in a later video. So let's take a closer look on this amazing part.
There's a golden sphere representing the Sun. It sometimes goes slightly faster than the date pointer and sometimes slightly slower. Below the Sun are Venus and Mercury. Both are also going with the date pointer but have retrograde motions. Sometimes they are in the right side of the Sun and at other times left of it. They are either visible in the evening or in the morning sky. The red pointer represents Mars. Mars needs 2 years for a full turn around the zodiac. Therefore, he is only visible every second year. The more distant white sphere is Jupiter, and the most remote is Saturn. Let's now take a look inside the mechanism. First, the gears for the backside, which I haven't fitted in my replica yet. On the left are the wheels for the calendar calculations, followed by the wheels for the eclipse predictions, and finally the gears for the lunar mechanism. The most interesting is the E3, E4 wheel with the epicyclic lunar mechanism, which I already showed in the last video. The slotted lunar wheel is now gray. The wheel simulates the varying orbital speed of the Moon and was actually found amongst the remains of the Antikythera mechanism. Let's now move on to the planetarium. First of all, I remove the frame, that is, the corners and the centerpieces that hold the whole thing together. Here we have the crown wheel A1, which drives the entire mechanism. And this is the base plate with a fixed axle for the lower Earth wheels, which do not move, which fits very well with the ancient geocentric model. Now I'm carefully removing the hands. The Sun hand, Mercury, Venus, the date hand, the Mars hand, Jupiter and Saturn. Here you can see the cosmos plate, and around the edge is a zodiac ring which indicates the positions of the planets in the sky. I'm now turning it upside down, and here we see the fully assembled planetarium. I'm now lifting out the main wheel along with the lower part of the planetarium. The main wheel B1 is driven by the input wheel A1. One revolution of the main wheel corresponds to 1 solar year. Here we can see the 4 pillars that hold the superior planets plate. Let's now quickly remove the Mars tube which belongs to the upper part of the planetarium. You can now see the nested tubes for the date, Venus, Mercury and the Sun, which transmits the movements upwards to the front plate. The pointers for the date, Venus, Mercury and the Sun are fitted onto these tubes. The date hand moves with the main wheel. 1 revolution corresponds to 1 solar year. As you can see, Venus, Mercury and the Sun generally move along with the course of the year. Venus sometimes moves retrograde and sometimes orbits faster along its path. This is simulated by the pin and the follower arm. The same applies to Mercury, and apparently also to the Sun, at least here in the geocentric model. Here you can see the Earth wheel, which is firmly mounted on the base plate and does not move at all. The date plate rests on these 4 short pillars and forms the lower part of the planetarium. It has a long tube at the top for the date pointer. Here we can see the superior planet plate, as reconstructed by Tony Freeth and Alexander Jones in 2012. On the right, shown here in red, are the wheels for Mars. At the bottom, shown here in gray, are the wheels for Saturn. And on the left, in white, are the wheels for Jupiter. They are each held in place on the planet plate by these small mounting brackets. I now remove the brackets. Each planet has a central output wheel with a small tube through which the planet's motion is transmitted upwards to the front plate. In addition, each planet has a slotted wheel that replicates the different orbital speeds, similar to the Moon mechanism with pin and slot. In the center are 3 more fixed wheels representing the stationary Earth, shown here in blue. They are firmly attached to the front plate and do not move. The planet plate is connected to the main wheel by the long pillars and rotates with it once per solar year. As you can see, the central Earth wheels do not move. Only the pin wheels representing the planets do. Now the slotted wheels are fitted onto the pin wheels. Here's another full rotation representing 1 solar year. Tony Freeth and Alexander Jones have chosen the same pin and slot mechanism for the reconstruction of the superior planets as the one that has been preserved for the Moon. These irregular motions are transmitted upwards via nested tubes. First comes a tube for Saturn, then Jupiter, and finally Mars. On the front side, you can see the nested tubes for Saturn, Jupiter, and Mars. The planet pointers are fitted onto these tubes, again in the order Saturn, Jupiter, and Mars. A quick turn shows the planetary motions, some of which are also retrograde. Let's turn the whole thing round again now. Now I'm putting the mounting tables back in place. Next, I take the base plate and remove the fixed earth wheel from it. Now comes the main wheel with the lower part of the planetarium. I carefully remove the pointers from it. Now for a slightly tricky part, as I have to slide the earth wheel into the main wheel here. It has to line up perfectly so that it snaps into place on the main axis. Have a quick go now to see if it still turns. Here's another view from the side. The main wheel mounted on the base plate. On top of that goes the superior planet plate with the upper part of the planetarium. Here we need to make sure that the pillars connect the base plate and the planet plate neatly. Now I'll start by assembling the corners of the frame and also the central brackets. And finally the drive wheel. Now I'll check that it turns again and that everything fits perfectly. Right, that's it, it fits. Finally, I'll attach the remaining hands, the date hand, the Venus hand, the Saturn hand, and last but not least, the Sun. And to finish off, let's check that the mechanism is still working. Let's turn the date hand once around the plate to simulate a full solar year. I hope you found the video interesting. See you next time.